All right, guys. So, first of all, I want to apologize for my voice. It's a little bit froggy still. But we're going to be starting a new unit, and the unit is called Permutations and Combinations. When you look in some textbooks, they also call it counting methods. And today we're actually going to be looking at something called the fundamental counting principle. So, normally, if we were in class, I'd be showing you an activity with Bobby the Bear. I'll post that activity to Google Classroom if you want to play with it and check it out a little bit. So we're going to look at a scenario here. It says that Laura is shopping for a sports utility vehicle, and the dealer says that she has 3 different models that she can choose from, and it's available in 5 different colors. So the diagram's already been completed for you. It says complete the tree diagram and determine how many different choices Laura has. So she can get either a Wrangler, a Patriot, or a Cherokee. And each of them comes in colors of black, blue, silver, red, or white. So that means she could have a Wrangler in black, a Wrangler in blue, and so on. If we go through and we count, take a look at how many choices she has. 1, 2, 3. Keep counting. She's going to have... If you count them all there, she's going to have 15 choices. Now, take a look back at the number of choices they have for each model, the number of choices for each color. So if you remember down here, we had 3 choices for model and 5 choices for color. And I want you to look at how the 3 and the 5 get us to a 15. And I'm guessing by now most of you have seen 3 times 5 is 15. So the dealer now tells Laura that she has a couple other choices. She has the choice of a standard edition or a limited edition. So if we go back up to the tree diagram and we start labeling our options, that means that we now have an SE edition and an LE edition. Or for the blue, we have an SE edition and an LE edition, and so on. So we could go through and add these all into our tree diagram, or we can look at the fundamental counting principle. And we know we had 3 choices for the first, 5 choices for the second, and now 2 choices for addition, giving us a total of 30 choices. All right, so let's look at the definition of fundamental counting principle a little bit more. So it says creating a sample space or a tree diagram for every type of question can be consuming. If you think back to what we just had here, if I wanted to write out all of those additions, it would take me some time. So an easier way to solve is using something called the fundamental counting principle. And that's right here. So the fundamental counting principle says that if there's R choices in the first stage, S choices in the second stage, and T choices in the third stage, the number of ways that a task can be completed is R times S times T, and so on. Now it's important to note that this only works when we're talking about AND. All right? This is when we're looking for 3 choices for the vehicle and 5 choices for color and 2 choices for addition. If an example involves AND, we find the total number of arrangements by multiplying. So, an example here, a toy manufacturer makes toys in 3 parts. Part 1 can come in blue or orange, part 2 can come in yellow, white, or green, and part 3 can come in purple or teal. So if we wanted to create a tree diagram, we're going to set it up using part 1, part 2, part 3. And so our options here, we have blue, and it's going to be blue or orange, and then after that, it could be yellow, white, or green. So yellow, white, or green. And then for the orange toy, it can also be yellow, white, or green for the second part. And our third option for the third part is purple or teal. So it's important when you're doing these diagrams, you try to give yourself enough space to spread out. We're going to have purple or teal, and so on. We go down to the orange top, same thing. So once we have our tree diagram, then we can just list our outcomes. So we can have a toy that is blue, yellow, purple, blue, yellow, teal, and I'll just go through and list our options here. And so once you have those, you can list them or you can count them all up, and we have 12 choices. Now again, if we're using fundamental counting principle, shorthand is FCP. Then we say that there's 2 choices for the first, 3 choices for the second, 2 for the third. 2 times 3 times 2 is 12 choices. All right, so let's take a look at when we're going to use fundamental counting principle and when we're not. So the first example, it says counting the number of possibilities when rolling a 3 or a 6 with a standard die. If we go back to our definition of fundamental counting principle, the key word is and. So when we're looking at these, we're going to be looking at and. So it says counting the number of possibilities when rolling a 3 or a 6. There's our keyword there. This is not fundamental counting principle. For counting the number of outfit variations when selecting a shirt, a tie, and shoes to wear for grad, this is fundamental counting principle. Counting the number of possibilities when picking the winner in a stock car race in either the 4th, 5th, or 6th race, not FCP. And the last one, counting the number of possibilities to choose from when renovating a kitchen. 5 color choices, 2 countertops, 3 backsplash, and 4 color options. There's our keyword. This is fundamental counting principle. All right, so let's take a look at an example here. It says a math quiz consists of 5 multiple choice questions. Each question has 4 choices, A, B, C, or D. We're going to use FCP to determine how many different sets of answers are possible. So when we're doing fundamental counting principle, we start by drawing out blanks, and each blank represents our options. Well, in this case, we have 5 questions, so we're going to have 5 blanks. Now, our choices for each blank go underneath. So our choice for the first one is A, B, C, or D. Our choice for the next one is A, B, C, or D, and so on. And then above those blanks is going to be our actual number of choices. And so for the first question, I have 4 possible choices. For the second question, I've got 4 possible choices, and so on. And because these are and, fundamental counting principle says to multiply. And so if I multiply that all out, I get 1,024 different ways to complete a test. It's important that you don't mix this up with probability. We're not talking about what's the probability of getting 100% on the test or what's the probability of getting a certain amount of questions right. We're just looking at how many different ways an answer key could be built for that test. All right, so when we're dealing with fundamental counting principles, sometimes we're going to come up with we're going to have restrictions that are put on us. Numbers have to be in specific positions. We can't have repetition, and so on. And so when we're doing questions that involve restrictions, it's important that you deal with the restriction first. So in our first example here, it says Cole has been asked to determine how many odd 4-digit numbers there are. And it's important for you to know that 5234 would be a 4-digit number, but 0137 is not a 4-digit number because the 0 doesn't have any significance in that place, so that makes it only a 3-digit number. So for this first question here, we're talking about odd 4-digit numbers. 4 digits means 4 blanks. And the last number has to be odd. Now, that's what we're going to deal with first. So odd means that it has to end with a 1, a 3, a 5, a 7, or a 9. There's no other restrictions, so we just start with the odd. If we consider how many odd numbers there are 5 odd numbers. Now, it has to be a 4-digit number, so that means at the start here, my choices are 1 to 9. I can't have a 0. So not 0. Now that would mean that my number of choices, if I count from 1 to 9, is 9 choices. Now in between here, these can be any numbers from 0 to 9. And it's easy to mix it up, but if you count all your numbers from 0 to 9, there are 10 choices. And again, using fundamental counting principle, we multiply this all out, and we have 4,500 choices. All right, now Cole's been asked to determine how many odd 4-digit numbers there are that have no repeating digits. So this is now going to add an extra element of restriction. So we're going to start off again with our 4 blanks. That's 4-digit number. We're still dealing with odd down here. And we're still dealing with numbers from 1 to 9 here. So we can't have 0. But now we also have no repeats allowed. So we start off with our odd. That means you have 1, 3, 5, 7, or 9. So there's still 5 options here. Now, if we consider repeating digits, we can't have any repeating digits. And so if we can't have any repeating digits, we've already used an odd number here. We can already have 1 to 9 here. That means we have 8 choices left. And then from here, we can have 0 to 9 and 0 to 9, but again, no repeats. So if I've already chosen a number for the back and I've already chosen a number for the front, that leaves me with 8 choices to choose from here and 7 here. And that gives me 2,240 choices. Now this one usually causes a little bit of struggle when we start thinking about no repeats. So I'm going to try to give you an example. So let's say I'm choosing a number and I know that my choices for the last one have to be odd. So I'm just going to write out all my numbers to choose from. All right, so let's say I choose my first number, and my first number is going to be 5. I still had 5 choices here, but now that I've used the 5, I have to consider how many options I have left. Now, I chose a 5, but this 5 down here means how many choices I have, not the number I picked. Okay, if you want to write the number I picked here. Now, my first number here can be from 1 to 9, and it can't be the one I've already picked. Well, if you look, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers to choose from, but I can't choose 0. That leaves me with 8 choices. So let's say that I picked that number to be a 7. Well, now I have 1, 2, 3, 4, 5, 6, 7, 8 numbers to choose from, and let's say I choose a 9. That leaves me with 7 numbers to choose from. Okay, maybe I choose an 8. Okay, so this was just an example, but this is still my number of choices here. All right, something to consider. Why can't you start with the thousands digit? Why can't we just say, okay, well, we don't want any repeats. This has to be 0 to 9 or 1 to 9. So I got 9 choices. Well, the reason we can't start is because that odd restriction has to be dealt with first. All right, so for the rest of this, we're just going to look at a variety of different examples and ways that you can be asked the same question multiple different ways. So the first example here, it says that vehicle plates in one particular country consist of a letter other than I or O, followed by 3 digits, the first of which cannot be 0, and then followed by any 2 letters which are not repeated. And it says how many different car number plates can be produced. All right, so again, we're going to start off by drawing out our blanks. There are 1, 2, 3, 4, 5, 6 elements in this license plate. So we're going to draw 6 blanks. So those are our elements that we're talking about. Our restrictions are going to go underneath. So we know that the first one is any letter, but not I or O. Now it says the next, it's followed by 3 digits. So these digits here are any digits from 1 to 9. It doesn't say anything about repetition, so we don't have to worry about that. And then it says it's followed by any letters here with no repeats. So any letters from A to Z, but no repeats. So again, start with your blanks, set up your restrictions, and then after that, you write in what the actual choices are. So we have 26 letters in the alphabet. So if we can have any letter except I or O, that's 24 choices. And it says the first letter here, so I missed this part here, 1 to 9, but the first one cannot be 0. So there's 10 digits, but if the first one cannot be 0, we've got 9. The next one is just a digit, and then A to Z, no repeats. Well, there's 26 letters, and once we use a letter, there's only 25 left to choose from. Again, fundamental counting principle says that we multiply. So that gives us 14,040,000 choices. All right, another way that you can be asked the question is pathway problems. So here it says there's 2 flights from Pelican Bay to Queensville and 3 routes from Queensville to Sanford, 3 routes from Pelican Bay to Renton, and 1 route from Renton to Sanford. So the pathway problem is set up here. First, you're going to figure out how many routes there are from Pelican Bay to Sanford passing through Queensville. Well, if we look on here, there are 2 ways to get from Pelican Bay to Queensville, and there are 3 ways to get from Queensville to Sanford. So we're going from Pelican Bay to Sanford, and we're passing through Queensville. So that means 2 times 3. There's 6 ways to get there. Now, certainly you could count them out to verify that if you would like. Then it says, how many routes are there from Pelican Bay to Sanford passing through Renton? Well, there's 3 ways from Pelican Bay to Renton. There's 1 way from Renton to Sanford. So 3 times 1 is 3 ways. Now it says, how many routes are there from Pelican Bay to Sanford? Well, if we're doing this, we can go from Pelican to Sanford going through Queensville, or we can go from Pelican Bay to Sanford through Renton, or in math means add. So there's 6 ways to go through Queensville, or there are 3 ways to go through Renton. 6 plus 3 is 9. So it's important for you to note that when we're dealing with or, when we're dealing with or, then we're adding. All right, so telephone number question. This would be something that we'd actually even have to deal with in our province, is making sure that we have enough phone numbers. You've probably noticed over the years that we've gone from having a 403 area code and a 780 area code to some other area codes as well. And that's because the more cell phones we have, the more phone numbers that we have, the more numbers we need to come up with, so the more combinations that we have to allow. So here's one example. It says the telephone numbers allocated to subscribers in one particular rural area consist of one of the following: the digits 345, followed by any three further digits, or, again, or means add, or the digit 2 followed by one of the digits 1 to 5, followed by any three further digits. So we're being asked how many different telephone numbers are possible. So again, we start off by listing our blanks. So for the first scenario, we can have digits 3, 4, 5. So this is a 3, a 4, or 5, followed by any other three digits. Or, and we know or means add, we can have a 2 followed by one of the digits 1 to 5, followed by any three other digits. So we'll go back to the first one. We have 3, 4, or 5, and then any other digits here from 0 to 9. And again, it says nothing about repeats. For the next one, we go to 2, and then any of the digits 1 through 5, and then any other digits. Again, nothing is said about repeats. So we list our options here. So there's only one way to pick a 3. There's only one way to pick a 4, one way to pick a 5. 0 to 9, there's 10 possibles, 10 and 10. Again, we multiply those out, and that gives us 1,000 possibilities. Now, for the second one, there's one way to pick a 2. There are 5 choices from 1 to 5, and 10 choices from 0 to 9. If we multiply that out, we get 5,000. So that means there's a total of 6,000 possible phone numbers. Now, if that particular community started to run out of phone numbers, they'd have to come up with more options or more combinations. All right, the next question here, it says, consider the number of distinguishable 4-letter arrangements that can be formed from the word hunters. Now, it's important, we're talking about distinguishable, that means different. 4-letter arrangements is important. And when we're arranging something, that means that we're just moving it around. So you could picture having some letter tiles, one with an H, one with a U, one with an N, and so on. So picture like Scrabble tiles. And we're taking those Scrabble tiles and we're moving them around. So in this case, we want 4-letter arrangement. So that means we're only going to take 4 of those Scrabble tiles and then arrange them. So 4-letter means that we have 4 blanks. It's really easy to miss the word 4, and so it's important that you're reading carefully, underlining and highlighting as needed. So any letter in any position. So we can have, there's 7 letters, so we have 7 choices, 6, 5, and 4 choices. So we have 7 letters to choose from, then 6, then 5, then 4. And that gives us a total of 840 combinations. So this one here had no restrictions. Now, what if we're told the first letter must be an H? We're still going to start with our 4 blanks, but this one has to be an H. So there's only one way to choose an H, and then there are 6 remaining letters to choose from. So 6, 5, 4. Notice as soon as we add restrictions, there are less combinations. So 120. So the next one says the first and last letters must be vowels. So again, it's still 4-letter arrangement, so 4 lines. But the first one has to be a vowel, the second one has to be a vowel. Again, remember that when we're doing arrangements, there's no restrictions. So that means these in here are consonants. Now, in case you need a little refresher, Vowels are A, E, I, O, and U. And in math, we don't consider the Y ever as a vowel. All right, so our number of choices for vowels. Our choices here are a U and an E. And so that's 2 choices. Now, once we take a vowel and put it here, then it leaves us with only 1 choice down here. For consonants then, we have 5 consonants. And once we've chosen a consonant, we've only got 1 left to choose from. So 2 times 5 times 4 is 40. Now the last one, at a glance, looks to be the same thing. However, we have to consider the position of the R. So the last one says the word. So this 4-letter word that we come up with has to contain an R. But in order to do this question, we have to consider where that R falls. So the R could fall in the first position, or it could fall in the second position, or it could fall in the third position, or it could fall into the fourth position. And so it's not just a matter of arranging it and having the R. It doesn't tell us where that R has to be, so we have to consider that as an option. Where is the R going to be? So for the first scenario, there's one way to choose an R in the first position, and that leaves us with 6, 5, and 4 choices, which we know from before, 120. There's one way for it to be in the second position, 6, 5, 4. Again, or means add. There's one way for R to be in the third position. That leaves 6, 5, 4 choices for the rest. And there's one way for the R to be in the last position. Now if we add that all up, that's 480 ways to create a 4-letter word that contains an R. Again, if you're confused with that one, go back and take another look at it. The difference between part 2 and part 4 is that in part 2, we're told specifically where the H has to be. Part 4, we're just told that the word has to have an R. So then we have to consider every possibility. All right, we're going to look at one more example, and this is a bit of an extension. Earlier, we were given a question where Cole was asked to determine how many 4-digit odd numbers there were. But when we're dealing with evens, we've got a little bit of a twist. So as an extension, Cole's been asked to determine how many even 4-digit numbers there are and how many even 4-digit numbers there are with no repeated digits. So we're going to start with the first one. Even 4-digit numbers there are with no other restrictions. So again, 4-digit number, we're going to draw our 4 blanks. Even means that it has to end with a 0, a 2, a 4, a 6, or an 8. And again, we know that our first number has to be 1 to 9. So if we consider our options, there are 5 even numbers to choose from. Okay. And then here we can't have 0. That leaves us with 9 numbers to choose from here. And my numbers in between go from 0 to 9 and 0 to 9. So there's 10 choices here, 10 choices here. So in this case, the work in the answer looks very similar to odd. Where the twist comes in is when we're having to look at having no repeats. Okay. So if we want to have no repeating digits, we're still going to start off the same way. Here we have our choices are 0, 2, 4, 6, and 8. And so there's 5 choices. The challenge comes when we get up here. We have 1 to 9, our choices. Well, if our last digit was a 0, then we don't have to worry about anything. We started with a 0 here. We have 9 choices here. But if my number at the end was anything other than a 0, then that limits my choices at the start. So when we're doing this kind of question, we have to consider 2 scenarios. we have to consider starting or ending with a 0, or not 0. So not ending with 0. All right, so we're going to write out our blanks again. And it's going to be one or the other, meaning we're going to be adding. So for the first scenario, let's say we end with a 0. That means we still have choices 1 through 9 here and 0 through 9 here. But again, for this entire thing, there are no repeats. I shall write that below. All right, so for the second one then, we're going to end with 2, 4, 6, or 8. And in our first line, still 1 and 9, but not our end number. So we'll come back to that one in a minute. So if we consider how many ways to end with a 0, well, there's only one way to end with a 0. Digits from 1 and 9 are 9. Now, I've already taken 2 numbers out, so that leaves me with 8 choices here and 7 choices here, which is 504 combinations. For the second part of it, if I end with a 2, 4, 6, or 8, that is 4 choices. Now, I have digits 1 through 9, and I can't use the one that I've already chosen. So normally I'd have 9 choices, but I've already used one of those numbers, so I have 8 choices. This one here can be anything from 0 to 9, except for the ones I've already chosen. Well, I've already chosen 2 numbers, so that leaves me with 8 choices here and 7 choices here. Again, this is one you may have to go back and look at a couple times, because that repeat part and that repeating part often causes some confusion. So OR means add, so we combine those two together. We have 2,296 choices. All right, so that's all the examples I have for today. There are some practice problems that you can choose to do. They are completely optional. I will be posting the unit review shortly, because you could just go straight to working on the unit review questions. All right, thanks and have a great night.